Hello everyone. Today we'll be looking at the topic proportions. First of all, we need to understand what is a proportion. A statement that shows two equivalent ratios or equivalent rate is called a proportion. Let us see some example. Let us say a ratio 2 to 3. A ratio 2 to 3 is equivalent to 4 to 6. If you multiply the first term by 2, we get 4. And at the same time, if you multiply the second term by the same factor, 2, we get 6. Hence, they are the equivalent rates or equivalent ratio. Another equivalent rate or ratio for 2 is to 3 can be 8 to 12. If you multiply the first term 2 by 4 times, we get 8. And the second term by same factor, we get 12. Therefore, we can also see that 4 is to 6 is also equivalent to 8 to 12. 4 when you multiply by 2 times and 6 when you multiply by 2 times, we get equivalent ratio. We can write this ratio or rates in the form of a fraction. 2 to 3 is equivalent to 4 to 6 is equivalent to 8 to 12. They are also like equivalent fraction. Let us understand more about proportion from the YouTube video.
The concept of proportion is very simple. All we need to do is understand a couple of simple examples. Assume you have a computer screen of the size 40 centimeters by 30 centimeters at home, and you've been asked to draw that screen in your notebook. What do you do then? You cannot draw a 40 centimeters by 30 centimeters screen in your notebook. Your notebook would be too small for that. So what you do is scale the size down. This term is very important. You scale the size down. It means you draw a smaller figure which is similar to the earlier one. You may draw a small screen like this, with length 4 centimeters and width 3 centimeters. This will fit into your notebook. Here, the ratio of the length to the breadth is 4:3. If you had a bigger book, you would have maybe scaled it down to 8 centimeters by 6 centimeters. In this case, the ratio of the length to the breadth would be 8:6. Let's talk about the first case. Why 4:3? The ratio of the length to the breadth of the actual computer screen is 40 by 30. When reduced, it can be written as 4 by 3. Basically, if we divide both the numerator and the denominator by 10, we get 4 by 3. Now let's look at the second case of 8 by 6. The ratio of the actual screen was 40 by 30. If both the numerator and the denominator are divided by 5, we get an equivalent ratio of 8 by 6. 40 divided by 5 equals 8 and 30 divided by 5 equals 6. What did you notice in this example? What are we trying to maintain? We are trying to maintain the same ratio. All the three ratios, 40 by 30, 4 by 3 and 8 by 6 are actually equal. We just changed the numerator and the denominator based on the requirement. Here, we had to draw a smaller screen and hence we reduced the numerator and the denominator proportionally. That's proportion. It's nothing but equivalent ratios. Let's take a similar example to understand proportionality. Look at this person. To sketch this person in your notebook, you would draw a proportional figure like this. All the elements, his height, his width, his hands, his legs, have been proportionally reduced. What if we would have drawn the figure like this? It can clearly be seen that this sketch is not proportional to the original person. Since it's not in proportion, the sketch seems to be a fatter person even though the person is lean and tall. This is all you had to understand in the topic of proportion. Now let's get back to our first example. Since 40 by 30 and 4 by 3 are equal ratios, we say that 40 by 30 and 4 by 3 are in proportion. And similarly, 40 by 30 and 8 by 6 are also in proportion. If you observed well, you'd say even these two ratios are equal. If we divide the numerator and the denominator of this ratio by 2, we get 4 by 3. Hence, we say that the ratios 4 by 3 and 8 by 6 are also in proportion. There's a special way to write it. We write it as 4:3, 2:, and 8:6. 4:3 simply is the ratio 4 by 3 and 8:6 is the ratio 8 by 6. And these two colons in between are used to denote equal ratios. It tells us that this ratio is equal to this ratio. Remember, proportion simply means equivalent ratios. And this symbol means the same as or equal to. So this can be read as 4:3 is the same as 8:6.
Now, let us see a question. In a classroom, 5 students were arranged in 2 tables. How many tables would be needed if there are 40 students in the class? In this case, so we have a ratio of tables to students. A ratio of table to students. That is 2 to 5. The ratio of table to students is 2 to 5. Now, we need to find out how many tables are needed if there are 40 students. So what we can do is 2 to 5 is equal to something over 40. We need to find a scale factor. If you look at the denominator, the first denominator is 5 and the second denominator is 40. How many times 5 will make 40? Yes, 5 times 8 will make 40. If the denominator is multiplied by 8, then we multiply the numerator by 8 too. So if you multiply 2 by 8, then we get 16. That means the class would need 16 tables. Let us look at some more missing terms in proportions. So there I have three different proportions with missing terms. Let us look at the first term, the first question. We have the first denominator missing. So let us see, the numerators are 3 and 18. How many 3's will make 18? 3 times 6 is 18. Therefore, which number when you multiply we get 30? Which number when you multiply by 6 we get 30? Or the other way we can do is 3 over something is equal to 18 over 30. Now, just the opposite of multiplications, 18 divided by 6 is 3. Therefore, 30 can also be divided by 6. So that will give you 5. Here, the scale factor is 6. Now let us look at the second question. In the second question, the second denominator is missing. 3 times 4 is 12. So 8 can also be multiplied by 4. So that is 8 times 4 is 32. Here, the scale factor is 4. Now, in the third question, again, the first numerator is missing. So either we can multiply from the first to the second fraction, or divide the second fraction to the first. So let us see. The denominators 15 and 45. 45 to get 15. If we divide 45 by 3, we get 15. So in the numerator also, we need to divide 12 by 3. So that it give you, yes, 4. So the scale factor is 3. Now if you look at this, when you multiply from first to second, we have shown the arrow from first to second. And when you divide, then we have shown the arrow towards the first. Now, whether you multiply or divide from which number to which term, then we need to show the arrow towards that. Many students make a mistake of writing the sign multiplication or division. Sometimes some people write like 3 over something and 18 over 30. Some of you are writing 3 times, okay. Then 6 times. No, this is wrong. The multiplication will be in the front. Now let us look at another question. Now let us look at what is unit ratio or unit rate. Unit ratio or unit rate is an equivalent ratio or equivalent rate with the second term of 1 unit. It will be more clear when you look at the example. For example, 2 kg flour makes 6 loaves of bread. How many loaves of bread can be made with 5 kg flour? So here, the ratio is between flour and loaf of bread. That is, the ratio is for 2 kg flour, we make 6 loaf of bread. Now we want to know for 5 kg flour, how many loaves of bread can be made? Now if you look at the term, the numerator 2 and 5, there is no way we can multiply 2 with a whole number to get 5. So what we can do is, (2 over 6) can be changed into 1 over something. That 1 is a unit term. Now 2, when you divide by 2, we get 1. So numerator is divided by 2. Denominator can also be divided by 2. Then we'll get 6 divided by 2 is 3. That means the second unit is in 1. That means the second term is in unit ratio 1. So now it will be easier for you to get for 5 how many loaves of bread can be made. So we can easily multiply 1 times 5 to get 5. So the denominator 3 can also be multiplied by 5, and we get there will be 15 loaves of bread. Answer is 15 loaves of bread. "30 gram of uncooked rice makes 105 gram of cooked rice. How much cooked rice will you get from 100 grams of uncooked rice? How much uncooked rice does it take to make 315 gram of cooked rice?" So this is an example from your textbook. Let us see this. The ratio is between uncooked rice in gram to cooked rice in gram. So if you put an uncooked rice in your rice cooker and cook it, after when you put 30 grams of uncooked rice, after you cook, the cooked rice will be 105 grams. Now our question is, if there is 100 gram of uncooked rice, how much cooked rice will it give? And the second is, if you are getting 315 grams of cooked rice, how much uncooked rice should there be so that you will get 315 grams of cooked rice? Now as you see, from 30 to 100, we cannot multiply or divide to get 100 directly. And if you take it to unit rate, so what will happen is, if you want to take it to unit rate, 30 divide by 30 and take it a unit rate, but 105 divide by 30 will be a problem. It will be in decimal. Although, if you are confident with the decimal, you can still go with the unit rate. So what we are going to do is, we are going to use some familiar terms. Now what we will do is, since 30 we can divide to get 10, and 10 we can multiply to get 100. So 30 divided by 3 is 10, and 105 we can easily divide by 3, and it will give a whole number, 35. Now 10 we can multiply by another 10 to get 100. 35 also we can multiply with 10 and we'll get 350. That means for 100 grams of uncooked rice, we are going to get 350 grams of cooked rice. And now for 315. If you look at this, 105, if you multiply by 3 times, we are going to get 315. So, even in the numerator, we are going to multiply by 3 times. So, 30 times 3 will be 90. Therefore, to get 315 grams of cooked rice, we need 90 grams of uncooked rice.